Good. I will now summarize what we have discussed so far, the summary of the course. We start with architectural definition. What is our software architecture definition? This is the one definition. That's the other one. Software architecture is fundamental organization of a system embodied in its components, their relationships to each other, and the environment, and the principles. This is from Kazman, Bas, Kazman, and Clemens. The software architecture of a program is the structure or structures, so defining multiple views which comprise software components, external visible properties of those components, and the relationships. So several other definitions we can also observe in the literature. These are actually two nice definitions, but there's also some common agreement on what architecture is in general, even though the definitions are not precisely the same. Architecture is gross level structure, including components and relations among these components. Why do we design architecture? There's some rationale for it. As we have said, it provides higher level of abstraction, embodies earliest design decisions, so this provides also better understandability, supports stakeholder communication, supports large-grained reuse, enables to evaluate the system before it's implemented, and management of software development activities. So all important issues which are important to define architecture. Architecture, every system has an architecture, is in some environment, and the environment influences the system. We said we have looked at the modeling of architecture. We have looked in three categories: architecture description languages, UML-based modeling of architectures, and architecture view modeling. Okay? The textual languages, the visual and modeling the architecture from multiple views. Architecture modeling can be visual or textual, as we said. Visual, we have looked at UML-based, and textual is architectural description languages. How to model architecture in UML? We have considered three different approaches. Either we use existing UML models as is. Second approach, you use UML's built-in extension mechanisms like stereotypes. And third approach, we introduce new notations to represent architectural elements. In this case, we have to change the meta model. This is the first approach. We just use the architectural UML as is, the elements, and try to define the architecture. The second approach, we use the built-in extensibility mechanisms, stereotypes, tag, values, and constraints. So, for example, we could have architecture to define architectural elements. And third approach, we introduce additional notations, but this requires to update the meta model. So in that sense, it's not preferred. The meta model of UML, in that sense, it's not preferred, okay, because it's not tool compatible. We have shortly discussed this. This is compatible with UML compliant tools, but violation of architecture components. This is compatible, but requires style specification. In the third approach, provides native support, but it's less preferable with respect to compatibility. Architectural description languages we have considered. We said the key motivation for this is that the primary motivation was that visual diagrams, no matter how precise you model them, could still be ambiguous. So we would like to define these in more precise notations, but not as programming language because they are too low level. So more higher abstraction textual descriptions. We have seen that elements of ADLs consist of three elements: components, connectors, and configurations. And based on that, different kinds of ADLs have been introduced and are still being introduced actually. There are some differences among these ADLs with respect to scope, focus on elements, and the goals. Some ADLs are general purpose, others are domain specific. to focus on elements, some focus on components, connectors or configuration, and the goals is the means for communication or part of a model. So especially with the second part, if it becomes part of the model, then we enter in the domain of model-driven development. We said that we have to define the multiple views of the architecture. The reason for that is that we have multiple stakeholders, many stakeholders, which have different concerns. And with respect to, again, the separation of concerns principles, we would like to provide one view for each concern. A view is a model of a system from perspective of one or more concerns which are held by one or more stakeholders. Okay, that's the summary here. I have seen this. We describe views by using viewpoints, which is a pattern or template from which to construct individual views. This is defined as in the this terminology of IEEE standard, recommended standard for architectural description, which provides the notions of view and viewpoint, not style, as we have, which was one of the questions in the quiz. It only describes view and viewpoint. That's stated here. The next one here. This is just a part. We have seen an example of a multi-view approaches. This is from Kruchten, Philip Kruchten, in which we had four viewpoints and one scenario viewpoint, and every viewpoint addresses different stakeholders and different concerns. This kind of 4+1 view model is also adopted in UML, as we have discussed. This is another approach which aims to actually categorize all these different kinds of views by asking three questions, by looking at implementation units, runtime units, and how the system is allocated to the environment. Okay? Based on that, they define not viewpoints but view type, okay, which is different from the IEEE terminology. So we have module view type, which could have different module views, component connector view type, and allocation view type. Besides of that, view types can be more constrained, then we get the styles. And as we said, you can define, there are some predefined styles, but also you can define some styles yourself. So you can constrain the view type by yourself, so then you have a more customized style, or you could even customize an existing style, as we have seen in the recovery style that we have shown. We had first the recovery style, then we also constrained that we had a local recovery style. Based on these styles, we can define multiple views. This is the predefined styles that in the views and beyond approach, where we have the four predefined styles. The component connector view type styles, these six, and the allocation view type, which maps software to non-software units, which could be, interestingly, to hardware, but also to a file system and to teams or people or organizations. Okay, so allocation of software to any non-software element. How should we choose the views? Well, typically produce a candidate view list by listing all the stakeholders and checking what kind of views they require. In this step, we had too many views, so we can combine the views. And the third step, we have to prioritize what to do first. Why? Because every view, defining a view, has some cost. You have to put time in it. Okay? We can also document behavior. That's with just the traditional techniques, like scenario interaction diagrams, collaboration diagrams, state diagrams, etc. All together, so we can provide some architectural document. Architectural document is a report consisting of actually the description of the views and some trans-view information. Okay? So in that sense, we could have the requirements document and related to that architectural documentation. We have looked at the software architectural patterns. This is the approach, so we have the architecture definition, we evaluate whether the architecture is okay. If it's not okay, we might refactor the architecture until it's okay. In the refactoring phase, we can apply architectural patterns. Okay, like we said, we apply domain-driven design. We have the module view, we can refactor using patterns. We have, what's a software architecture pattern? It's a pattern at the gross level structure. This is actually the volume. We have discussed some patterns of this book, but there are also other books on architectural patterns. This is an example of layers pattern, as we have seen. So where you have to structure the system into several layers. This is an example, so where we have 3 layers and data storage has some database layer. We have considered these patterns, the layers, bytes and filters, blackboard, modular view controller, broker, and some composition of these patterns. Okay. So modeling and architecture description language, views, approaches, and patterns. So how do we design this architecture? We said, so what is architecture design method? So typically you have these components, okay, and what does it mean? How to use these artifacts to define a software architecture. Different architecture design methods can be identified in the literature. So which one should we select? We said we can classify these based on the scope. The scope, if we focus on single system development, then we have typically a single system architecture, which was actually the focus in this course. But if you have a multi-system scope, nowadays more and more organizations provide that view. So instead of defining an architecture for a single product, they want to define an architecture for multiple products. Then we get in the software product line architectures domain, which is a different course actually. But there we make a distinction between reference architecture and application architecture, or product line architecture, representing the architecture for the whole set of products, and application architecture, the architecture for one product. As I said, this is discussed in the course of software product line engineering. A second approach to classify the architecture design methods is by looking at the source of the architectural abstraction. How do you derive the architectural abstractions? In that case, we can define 4 different types of methods: domain-driven, artifact-driven, use-case-driven, and pattern-driven. In the artifact and use-case-driven, we basically look at the requirements and try to actually somehow more implicitly map from the requirements to the architecture directly. Pattern-driven approach, what you do is, based on the requirements, you select the right kind of pattern, and based on that you define your architecture. And domain-driven approach, as we said, which was the focus also in this course, you derive the abstractions from domains. So by first looking at defining the technical problems, identifying solution domains, identifying knowledge sources, doing commonality analysis, and based on that define the solution domain, the domain architecture, the conceptual architecture. An example of domain-driven approach is the synthesis-based software architecture design, which we have also followed in the project, where we did the requirements analysis, technical problem analysis, solution domain analysis, and architectural design. Okay, so we have the method, the models. Then after that, actually, once we have the architecture, we have to evaluate the architecture, evaluate as early as possible to analyze the qualities, to analyze before we enter in the damage control. Okay, so we should be sure that the architecture is stable, that it meets our stakeholder concerns. We have seen again, this is summary with the we have seen different architecture evaluation techniques, among which scenario-based analysis approach has been explained. This is the approach, as we had said, so architecture definition. We derive scenarios based on the stakeholders. We evaluate the architecture with respect to scenarios. Once the architecture meets the scenarios, we realize, if not, we have to redefine. We have seen this approach consisting of 5 steps: describe architecture, develop scenarios, perform scenario evaluation, review scenario interactions, and generate overall evaluations. This is actually another method, architecture trade-off analysis method. Unfortunately, we did not have time to explain this, but here this again is defined by Carnegie Mellon Software Engineering Institute. It's also a successor to SAAM. Here the purpose is to assess the consequences of architecture in the light of multiple quality attributes. SAAM is actually basically focusing on modifiability. Actually, these are the quality attributes. So I will shortly explain. This is what is the key in this case is what they define as sample utility trees. So based on the quality concerns, they derive specific scenarios. Okay, in SAAM it was more like asking the stakeholders, so provide your scenario. Okay, here's the ideas from what are the quality concerns, and define the scenarios based on these quality concerns. Based on these scenarios, they evaluate very shortly, so it's more detailed, of course. They evaluate the architectural patterns that are applied in the software architecture, and then they check whether they are the right patterns, or what are the risks, what are sensitivity points, what are the trade-off analysis points. So that's actually in a very fast way I have summarized all the issues that we have discussed. For the exam, what should you know? Actually, there are different questions that we can derive. For architecture modeling, you should know why do we need architecture, how to model software architecture in UML, what are the limitations of architecture design methods, design modeling techniques, what is 4+1 view model, why do we need different views, what are the different view types, what is the relation between view type, style and view, how to choose views, what are architecture description languages, what are the common and difference among these, what is the role of use case in 4+1 view model and other use case driven architecture design approaches. Okay. What are different software architecture design approaches? We have seen different methods. Why are client requirements use case not a solid base for architecture design abstractions? You should know that by now. What are the obstacles of the architecture design approaches? What are different requirements and analysis techniques for architecture design? What are stakeholders? What is their impact? What are architectural drivers? Okay, drivers based on stakeholder concerns. What are the problems of multiple stakeholders for architecture design? You have to do trade-off analysis. What is domain analysis? Different interpretation of domain analysis. Why is domain analysis crucial for software architecture? What are different sub-processes in domain analysis? What are the obstacles of uncontrolled domain analysis? How do we control domain analysis? By technical problems. We identify the problems so that we can scope the domain. What's the knowledge source? How to evaluate these knowledge sources? What is abstraction quality? We look at objectivity and relevance. What is the relation between concepts, domain, knowledge source, and concept? What's the domain lexicon? Why is it important? What's the conceptual domain model? What is domain scoping? Why is it important? What is future-oriented domain modeling? How to use it? So I guess you know all these, the answer to these questions. So, what is the synthesis-based architecture design approach? What is the role of technical problem analysis in Synbad? Is scoping the domain, as we said. What is the role of classification of knowledge domains? It helps to identify the right domains. What should be done if domain knowledge is lacking? Either you do research or you stop you cannot define the architecture. So you do feasibility analysis. What is the relation between technical problem, solution domain and concept? Why do we need to iterate between technical problem analysis and domain analysis? That you have seen this, actually observed this also in the project. It's not easy to define the problems right from the beginning. So you have to get some knowledge on the domain. We have seen the patterns, what the pattern is, the different kinds of patterns, what is the difference between a pattern and conventional design, why do we need patterns, when to apply a pattern in the software lifecycle. In our case, we defined first the domain model, and then we applied the patterns. So it's actually a domain-driven approach, complemented with pattern approach. We have seen several patterns, which we have also applied in the project. How to apply and compose architecture patterns. Typically, you don't have just one pattern, but you could have multiple patterns. Your architecture could be based on one dominant decomposition, based on one pattern, but it can also include composition of patterns. How to apply and compose architecture patterns. So we could have, for example, a dominant decomposition layers pattern, and we could have one layer could be a pipes and filters approach. What are the limitations of a pattern-driven approach? Architectural evaluation, finally, what is software architecture evaluation? Why is it important? What are the risks of software architecture design approaches? What's a scenario-based evaluation approach? How to extract these scenarios? What is a scenario interaction? What are good or bad scenario interactions? What is cohesion and coupling? This is very important principles in separation of concerns. What is the relation of scenario interaction and cohesion and coupling? What is SAAM? What are benefits and limitations of SAAM? So plenty of questions actually that we have actually somehow addressed in this course. Of course, there's a follow-up, can be a follow-up on this in this course, but we have actually tried to define the first basic concepts of software architecture design. We had 3 goals in mind here: learning the key concept of software architecture design, experiencing the software architecture design process, and providing insight in the best practices and obstacles of software architecture design. We have done this by looking at the textbook, the lectures, experiencing. So this course was really project focused, project based. Lots of time has been focused on that, and I think this was also one of the most important issues. So you have just experienced the whole process, you did it yourself, and while doing that, I hope you have you got some insight in this whole matter of architecture. As I said, these are the key concepts that we can even further refine it, but I think we have now addressed all the key concepts of architectural modeling, architectural methods, and architectural evaluation. That's actually the course, and thank you very much for your interest and attention in this course. Any questions about the final questions? No questions. Okay, Wednesday we will just finalize with the project presentations. I see you then.